Today everyone, in this video we'll be going to discuss what is glass as forensic evidence, what is glass fracture, the different types of glass fracture, path of a bullet passing through window glass, and how do we know which glass penetration came first. So, what is glass? Glass is a mixture of silicates. It is amorphous, hard, transparent, brittle, supercooled liquid with infinite viscosity formed by fusing a mixture of sodium carbonate, calcium carbonate, and silica. Because glass is made of a variety of compounds, there are many types of glass, and here are the example of the different types of glass. Adding different metal oxides to glass mixtures, for example, yields different colors, just like this. And because different types of glass have different densities and refraction indexes, it is possible to compare one type of glass with one another.
Glass as forensic evidence. Glass as a physical evidence is frequently occurred in various crimes such as vehicle incident, burglary, murder, shooting incidents, arson, and vandalism.
Glass fracture. Fractured glass reveals information about the force and direction of an impact. This information may be useful for reconstructing events at a crime scene investigation. So, there are two main types of glass fracture. These are radial fracture, or what we call primary fracture, and concentric fracture, or what we call secondary fracture. So, what is radial fractures? So, radial fractures are cracks that start at the century at the point where the object struck the glass. It is the radiating lines are appropriately known as radial fractures. These fractures are originated on the surface opposite to impact or blow of force. This is the example of radial fractures. Concentric fractures. It is the circular lines in the glass around the point of impact are known as concentric fractures. They are in the form of a series of broken circles around the point of impact or blow of force. So, concentric fractures originated from opposite side of radial fractures. So, these are the example of concentric fractures.
Observing the path of the bullet passing through the window glass, the entry hole will be round if the bullet was fired perpendicular to the pane. Moreover, if it is fired from an angle, glass pieces will be forced out to the opposite side from the shot. The angles of which bullets penetrating the window glass can help locate the position of the shooter. Bits of glass can fly backward, is also called as the backscatter, could help possibly create the trace evidence.
And now we will be sharing with you our reenactment regarding glass penetrations. As you can see, it was fired perpendicular to the pane. As you can see, there are two bullet holes. So, that is our first penetration and that is our second penetration. So as you can see, there are lines radiating out, that what we call as radial fractures. So this is our entry hole and that is the point of impact. Yes, that is the point of impact and that is our point of impact. As you can see, there is a circular one, that what we call as a concentric fractures. Since it was shot perpendicular, our entry hole will be round. As you can see, it is round. So these are the fragments that were pushed out from the center, which can be used for trace evidence. So that's our penetration. So here is our first penetration. We can actually see very well that the fractures were formed by the penetration. We can actually see the radial fractures radiating out from the center and the concentric fractures that form arc or circular pattern or spiderweb pattern all around. If we look from the side, the glass itself, we fell smooth right up to the edge of the penetration. We fell smooth here in the edge of the penetration. Here we can see our second penetration. So this is our second penetration. If we look very closely at our penetration, they seem to run in together. We can see the radial fracture here, the radial fracture from our second penetration, reading it out with our concentric fractures from our first penetrations. How do we know which came first? Well, if you look very closely at our penetrations, you can see there's a radial fracture here coming from our second penetrations here that stops when it hits the radial fractures coming from the first penetration down here. Radial fractures from later impacts always stops when they reach the radial fractures from our earlier impacts. So this is our earlier impacts and this is our later impacts. So we can tell that the lower penetration came first because its radial fractures go all the way here, and our upper penetrations came second because its radial fracture here, the radial fracture, stop right there when they meet the radial fractures from the first penetrations. Here, the radial fractures coming from our second penetration stops when it hits the radial fractures coming from our first penetration. Let's take a look on the other side, or what we call as exit hole. Let's look at the fracture itself and the penetration. So once again, we can see our radial fractures. These are the radial fracture, and our concentric fractures. These are the concentric fracture. These are the concentric fractures. So if we look very closely at the edge of the penetration, you can see it slopes in toward the center of the penetration. That slopes in. So that's what we call a crater. And what we're actually observing right now is the crater effect, essentially to the opposite side from where the force, or this case the projectile, came from, forms a cratered appearance. So in this example, that forms a cratered appearance.
Entrance and exit hole. Remember that the point of entry is where the force is being applied, and it may produce a smaller hole than the exit. The exit is bigger than the entry for the reason that the force applied at the glass exceeded its desired force. Point of entry has a smooth hole, has the characteristics of roughness.